Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 2nd, 2025, about 4 days ago. This paper introduces a lifelong editing framework that boosts editing accuracy by 10 to 30% across multiple model families, while significantly reducing knowledge forgetting. The paper is titled Repair: Robust Editing via Progressive Adaptive Intervention and Reintegration. And as we'll see later, the implications for reliable model updates are quite significant. In short, it combines closed-loop feedback, dual memory with dynamic routing, frequent knowledge fusion, and strong locality guards to deliver precise, low-cost edits without collateral damage. That setup framed the goals. Figure 1 maps the problem areas and the proposed fix in one flow. The figure presents closed-loop feedback, which means the system checks the effect of each edit and triggers re-editing when errors appear, so updates stay stable. On the left, the pipeline merges and fuses edits from an edit dataset. On the right, the loop applies in batch distillation for generalization and prunes bad shards before reintegration. So Table 1 compares editing methods across 3 fronts: memory design, desired attributes, and behaviors. The table uses check marks to indicate strong support, crosses to indicate weak support, and circles to indicate partial support. Locality here means edits stay targeted, so unrelated facts remain stable. The left block lists long-term memory, working memory, and parametric updates. The rightmost block highlights behaviors, showing error feedback and knowledge distillation as distinctive strengths. Alright, Table 1, Contrasted Capabilities. Figure 2 shows how the closed-loop editor actually runs. The pipeline stores each edit as a small parameter update, called delta theta, in a side memory, which is an auxiliary store that holds targeted patches. An error monitor tests new inputs, so edits that cross a failure threshold get pruned. In batch distillation then groups similar samples to generalize the fix, and data reintegration feeds hard cases back for continual learning. Figure 2 outlined the loop. Table 3 reports how that loop performs across models and edit scales. The table compares reliability, generalization, and locality, plus an overall score called OP, which means the geometric mean of those 3 metrics, so weak spots matter. Repair leads on most rows, and it stays strong as the number of edits grows, because the feedback and memory pruning prevent conflicts. Competing methods often drop sharply at large N, especially on locality. So the big takeaways are clear. The closed-loop editor with dual memory and frequent knowledge fusion delivers around 10 to 30% higher editing accuracy while keeping locality strong, even at large scales. The broader implication is cheaper, safer, lifelong updates that curb hallucinations and avoid retraining churn. Thanks for listening. I am Alex, and this is the AI Research Roundup.